For an atom to become a compound, there must be exchange in their valency. So we need to know that. A compound form as a result of combination of one or two elements. So let me give an example. If you have element A combine with another element B in order to give you another product, to give you another thing like AB. In this type of illustration, it's telling us that we have element A combined with B to form AB. So this A is our element, and B is also an element. This AB is the compound that we are going to. So now I'll have something like this: A plus B to form what? To form AB. So this is the compound. So for an element to become a compound, there must be exchange in their valency. So that will take me to what is called valency. Valency. So we need to know what valency is. Valency is the combining power of an element, or is the number of electrons in the outermost shell. Valency is the combining power of an element, or is the numbers of electrons in the outermost shell of an electron. So let's take, for instance, for this from this first example where we have A. Let's say A has the valency of 2, and B also has another valency of, let's say we have 3. So for this to become a compound, there must be exchange of their valency. So the product will now have A3 B2. So from here we can see that there is exchange in their valency. So that is one of the parameters that we need to look into. For an element to become a compound, there must be exchange of their valency. Now let me take us through how we can determine our valency. Okay, let's take, for instance, we have from the first illustration where I gave the position of each of the atomic number. So let me just carry one out of it. Let's say we want to make use of sodium. We can see that sodium is here. Sodium is here with atomic number 11. So I will take sodium as an example. Let's say we have sodium. This is our sodium, and it has an atomic number of 11. So we need to find the valency of this. By doing that, so we make use of we make use of what is two laws. We make use of two laws. One of the law is duplet stability. Duplet stability. What this law states that, it states that for an atom to be stable, the innermost shell must contain 2 electrons. 2 electrons. That is for the first law, and we have the second law, which is Oxley's stability. What this one is saying is that for an atom to be stable, the outermost shell must contain 8 electrons. I will illustrate that. The innermost shell must contain 2 electrons, and the outermost shell must contain 8 electrons. So let's say we have this is our nucleus of an. Let's say we have atom. Let's say atom of. We want to work on atom of sodium. We want to work on the atom of sodium, and we want to make use of these two laws, the duplet stability and the Oxley stability. So what this one is saying is that the innermost, let's say this is the shell. The innermost must contain 2 electrons. This is the first electron, and this is the second electron. And we can see that sodium has atomic number of 11. So if I remove 2 out of 11, okay, let me put it here. We have 11. If I remove 2 from this 11, we have 9. we have 9. So this is the first two, we still have 9. So it will undergo the second law, which says the outermost shell must contain 8 electrons. So that means I'll have to arrange another shell here where I will distribute my electron, 8 electron. 1, 2, 3, 4, 5, 6, 7, 8. So I'll have 2, 8 here, remain 1 from this 9. So I'll put that 1 here. So now this is the 1. I will not. This is the 1. So that means sodium has the arrangement of 2, 8, 1. So this is the valency that we are talking about. From the definition, I said valency is the combining power of an element, or is the numbers of electrons in the outermost shell. We can say from here that after we arrange our electron in the shell, we have 1 here. So this is the outermost shell. So the valency of our sodium is 1. The valency of our sodium is 1. So let's say we want to make sodium to combine. We want to make sodium to combine with another element. Like let's say like chlorine. You want to make sodium to combine with another element, chlorine, so that we have sodium combined with chlorine. So what we have here, we know the symbol of sodium to be Na, and we have this the symbol of chlorine to be Cl. So what we are interested in now here is to know their valence, and from here we know that valency of sodium is 1, since there is 1 electron. There is 1 electron in the outermost shell. So we have sodium like this, sodium 1. So in case of chlorine, when we check from here, we can see that chlorine is in atomic number 17. So chlorine is atomic number 17. So from that, we'll say chlorine has the atomic number of 17. From this atomic number of 17, we'll allow it to undergo the same duplex stability and the octet stability. And we know that from the duplex stability, the innermost shell must contain 2 electrons, while the outermost shell must contain what? 8 electrons. 8 electrons. So what we are going to do is this. We have chlorine to be 17, admit the atomic number. So we are going to arrange it now in the shell. So let's do it like this. The first shell must contain 2 electrons. Okay, let me put my first one. Let me put the second one here. So we have 2 electrons. When you remove 2 from 17, we have what's that? We have 15. So we put another shell here. We'll put another shell here where we'll put our 8 electron, because this is outermost shell. This is the another shell. You can see there is 8 electron here now. So I will put my 8 here. 2 plus 8 is 10, so we still have 7. So we'll put 7 here. So here we put 7. 1, 2, 3, 4, 5, 6. So this is the remaining one, 7. So we can see that chlorine has 7 electrons in the outermost shell. But now we can see that for this one to obey the oxalate stability, for chlorine to attain oxalate stability, we need another 1 electron. So which means chlorine needs to borrow 1 electron in order to become oxalate stability. So in case of this, we'll write chlorine to be equal to chlorine negative. In case of this sodium loses 1. We can say that sodium loses 1 electron. Instead of me to put 281, I write it to be what? I put it to be 28. So chlorine loses 1 electron to become what? Positively charged. While here chlorine loses 1 electron to become what? Negatively charged. So this can also give us insight to define what is metal and non-metal. So I will simply say, okay, before going to metal and non-metal, let me just put it like this. Sodium, which has a symbol of Na, loses 1 electron to become Na positive. So you can see that the numbers of electrons that he gain or lose, the numbers of electrons that an element gain or an atom gain or lose is their charges or their valency. So in case of sodium has 1 valency because it loses 1 electron, and chlorine too has 1 valency electron because it gained 1 electron. So here what I will do here now is I will say sodium combined with chlorine to form sodium chloride. Here we can see that they exchange